Section 1.3, Collecting Sample Data. The method used to collect sample data influences the quality of the statistical analysis. Of particular importance is the simple random sample. If sample data are not collected in an appropriate way, the data may be utterly useless that no amount of statistical torturing can salvage them. The gold standard, randomization with a placebo and treatment groups, is sometimes called the gold standard because it's so effective. A placebo is a sugar pill that has no medicinal effect. Statistical methods are often driven by the data we collect. We typically obtain data from two distinct sources: observational studies and experiments. An experiment applies some type of a treatment and then proceeds to observe the effect of that treatment on the individuals. The individuals in the experiment are called experimental units, and they're often called subjects when they're people. An observational study, we simply observe and measure specific characteristics without attempting to modify the subjects being studied. An observational study, here's an example. Observe past data to conclude that ice cream causes drownings based on data showing an increase in ice cream sales are associated with an increase in drownings. The mistake here is to miss the lurking variable of temperature and the failure to see that as temperature increases, ice cream sales increase and drownings increase because more people swim. We could do an experiment in the same situation where we have one group treated with ice cream while another group gets no ice cream. Then we could look to see if the rate of drowning victims is about the same in both groups. So here, the experiment is clearly better than the observational study. However, the logistics of doing that may be nearly impossible. Design of experiments. Replication is where we repeat an experiment on more than one subject or perhaps even more than one group of people. Good replication requires sample sizes that are large enough so we can see the effect of the treatments. Blinding is a technique where the subject doesn't know whether he or she is receiving a treatment or a placebo. And in fact, if you see the word placebo in a study, then you know there's blinding occurring in that study. And it's a way to get around the placebo effect when the untreated subject reports an improvement in symptoms even though they didn't really receive a treatment. Double blind. Blinding can occur at two levels. The subject doesn't know whether he or she got the treatment, and the experimenter doesn't know. Randomization is used when subjects are assigned to different groups through a process of random selection. The logic is to use chance as a way to create two groups that are as similar as possible. Simple random sample. It's selected in such a way that every possible sample of the same size n has the same chance of being selected. It's often called just simply a random sample. Systematic sampling, we randomly select a starting point and then we select every kth element in the population in order to get to the sample size that we desire. This is often used in manufacturing to select samples for quality control testing. Convenience sampling, this is where we use data that are easy to get. This is like the voluntary response that we talked about in the last section. Stratified, we divide the population into at least two subgroups or strata, so the subjects within each group share the same characteristics, and then we draw a sample from each of the subgroups. Cluster, divide the population into regions or sections, and then randomly select some of those clusters and choose all the members from the selected clusters. This is sometimes called geographic sampling. Multistage, you can use a combination of the basic sampling methods that we just went over. Observational studies, the purpose here is to observe and measure but not modify. And we have three types. Cross-sectional, this is a point in time, so this is like a survey. We collect data at one point in time, not over time. Retrospective or case control study, we go back in time, we identify the subjects and then go back through data and identify information that's useful or data that we want to analyze. Prospective, we identify the subjects or cases and then we track them forward. Confounding occurs in an experiment when the experimenter is not able to distinguish between the effects of the different factors. We try to plan the experiment so confounding does not occur. Some ways to control effects of variables are in the study design. A completely randomized design assigns subjects to different groups through a process of random selection. A randomized block design is where we block the subjects into groups where they have similar characteristics and then randomize within those blocks. Statistically, we can remove the effect of the block through the analysis process. And then match pair designs is where we have two treatment groups that have somehow matched the two groups. Sometimes it's the same subject or sometimes they're matched based on similar characteristics. Rigorously controlled designs carefully assign subjects to different treatment groups so that those given each treatment are as similar as possible. And this is really important in a good experimental design. No matter how well you plan and execute the sample collection process, there's likely to be some error in your results, which we call sampling error or random sampling error. And it occurs when the sample is selected with a random method, but there's a discrepancy between the sample result and the true population result. And this just happens from random chance variations. Non-sampling error is the result of human error, and this could be things like wrong data entry, computing errors. This is where the questions are biased in the survey, false data provided by respondents, forming biased conclusions, etc. Non-random sampling error is a result of using a sampling method that's not random, such as convenience or voluntary response sample. Identify the type of sampling used in each situation. Cormorant bird population densities were studied by using line transect method with aircraft observers flying along the shoreline of Lake Huron and collecting sample data at intervals of every 20 kilometers. Notice there's a systematic collection of data there, that's systematic sampling. In a Kelton research poll, adults 18 or older were called after their telephone numbers were randomly generated by a computer, and 36% said they believe in UFOs. This is a random sample. A professor surveyed a sample from the population of his statistics class by identifying groups of males and females and then randomly selecting 5 students from each of the 2 groups. This is stratified sampling. Each of the groups has a common characteristic, in this case, 1 group of males, 1 group of females. A student conducted a survey on driving habits by randomly selecting 3 different classes and surveying all the students as they left those classes. Cluster. The sexuality of women discussed in Sherry Height's book, Women in Love, A Cultural Revolution, her conclusions were based on sample data that consisted of 4,500 mailed responses from 100,000 questionnaires that were sent to women. This is convenience sampling. Is this an experiment or an observational study? In a survey conducted by USA Today, Internet users chose to respond to this question posted on the USA Today electronic edition. Is news online as satisfying as print and TV news? 52% of the respondents said yes. It's an observational study. What's a major problem with this? This is convenience or voluntary response sample. Physicians' Health Study involved 22,071 male physicians based on random selections. 11,037 were treated with aspirin, and the remainder were given placebos. The study was stopped early because it became clear that aspirin reduced the risk of myocardial infarctions by a substantial amount. Okay, so this is an experiment. 1 group got aspirin, 1 group didn't. Major problem was it only involved male physicians. It would be better to use males and females who are non-physicians. Identify the type of observational study. Phase 2 of the Nurses' Health Study was started in 1989 with 116,000 female registered nurses. The study is ongoing. This is a prospective study. Researchers from the NIH want to determine the current rates of marijuana consumption among adults living in states that have legalized the use of marijuana. They conduct a survey of 500 adults in those states. That's a cross-sectional study. And then finally, samples of subjects with and without heart disease were selected, and then the researchers looked back in time to determine whether they took aspirin on a regular basis. That's a retrospective study. Identify the most appropriate study design. And we have 3 choices: completely randomized, randomized block, or matched pairs. Lunesta is a drug designed to treat insomnia. In a clinical trial of Lunesta, amounts of sleep each night were measured before and after the subjects had been treated with the drug. That could be a matched pair, because we could have the sleep for each subject before they got drug and then the sleep after they got the drug. A clinical trial of Lipitor treatments is being planned to determine whether its effect on diastolic blood pressure are different for men and women. Because we have groups that might have different effects, we want to use a randomized block design. Currently, there's no approved vaccine for the prevention of infection by West Nile virus. A clinical trial of a possible vaccine is planned to include subjects treated with the vaccine while other subjects are given a placebo. So there's no matching here and there's no subgroup, so we're going to just do a completely randomized design.